fine.
Okay, so 216, we multiplied polynomials. The key thing here is to make sure everything in one polynomial multiplies everything in the other polynomial. Make sure you pair off everybody. So if you had 3 terms to multiply 4 terms, you'd have to just live with temporarily getting 12 terms, because you'd have 12 ways to pair those off, because 3 times 4 is 12. They did nothing that big. Number 1 though, they did 3 terms times 2 terms. So for a minute, you're going to get 6 terms. Why is that only for a minute? Why aren't they going to just stay 6 terms forever? Because we're going to be able to combine some like terms to get these down a little bit smaller than where we would have been in the wrong big answer. So let's do a come around. We'll see how this treats people. Did you get to that? To 1?
6x cubed plus 4x squared plus 34x minus 64.
That's all true. Number 2 should have 4 terms.
6y cubed plus 3y squared plus 36y plus 27.
Okay, I disagree with your 36y, but I like everything else. We'll skip ahead a person. Do you have some other amount of y's that's not 36? On number 2?
Number 2. You just want me to say it.
It's I agree with 6y to the third plus 3y squared plus some y's plus 27. It's just a question of how many y's.
9y.
It is 9y. I agree with that. 3, you get the biggest, baddest one. 1, 2, 3, 4, 5, 6, 7. There are 8 terms in this. When you first FOIL it, there's 9, and then only 2 of them combine. So this is where descending order comes in handy. So ideally, we'd like to start with the a to the third stuff first. Use the b's as tiebreakers. The a squared stuff next. Use b's as tiebreakers, like on down the list. But I'll try to cover these with my fingers and thumbs, because my book did not put these truly in descending order. They're in random order, so it'll make this hard. So go a little bit slow. What do you think?
Oh, I have to slow the rest of my words. 4a to the third b squared.
Yes.
Minus 10a squared b squared.
Yes.
Plus 4a squared b.
Yes.
Plus 3ab cubed.
Yes.
Plus 4ab squared.
Yes.
Minus 2ab.
Yes.
Minus 6b cubed.
Yes.
And then plus 3b squared.
Yes. If you had a microphone, you should just drop it and walk off. Just walk off the stage. If you can do 3, you can do anything in this chapter. That's as big as anything you're going to see. 4, it started off equally big, but when you consolidate, there must be some like terms or some like eliminations. You'll get down to 5. You weren't here yesterday, but did you get a chance to do that?
Yes, I got 6 terms though.
Okay, why don't you start giving me what you have, and when we find a point of disagreement, we'll get some help from down the line.
Alright. 2x to the 4.
Yes.
Minus 4x squared y.
There's not a 4, there is a minus 4 thing, but not that, and there is some x squared, y squared stuff, but not that.
Okay, so minus 4x cubed y.
Yes, that's there.
Plus 3x squared y squared.
That probably combined with a friend.
Okay. Minus 2y to the 4th.
That's there.
Plus 3xy to the 3rd.
That is there, yes. So I agree with 4 out of her 5. So 2x to the 4th, yes. Minus 4x to the 3rd y, yes. Minus 2y 4th plus 3xy 3rd. Just what we're hunting is an x squared y squared thing. Can you fill in the blank on that one, or do you have an x squared y squared thing, or no? Yeah, that's the one we need. Yep, so if we take the first 4 we got and sprinkle in a negative x squared y squared, then yeah, we're good. I'm guessing that came from combining, I think there was a positive 2 of those, and then maybe like, I'm not sure.
There was a positive 2 and a negative 4, and then like
Another one later too?
just a normal one.
Okay. So 3 of those
Yeah,
made
so
1?
it was just like an x squared, y squared, and there was also a minus 4x. x squared y squared. And then a plus 2x squared.
All right. 5, you'd start off with 6 terms, but it shrinks real fast. 6 only has 2 survivors. Or 5 only has 2 survivors. Do you have 2
A
survivors?
cubed, B cubed, minus.
Yeah, a cubed minus b cubed. 6 is similar. There were a lot of terms, but there's only 2 that survive. When we combine, some disappearing acts happen. Do you have a 2-term final?
Number 6.
On number 6?
T3 plus 1.
It is 2 to the 3rd plus 1. Yep, 2 terms lived on. They started with the worst ones first. Does anybody need any help on the 1 to 6 life? Okay, then not to make people feel bad if you make mistakes, but the next group gets easier. Okay, and the next group is true foiling, meaning there's 4 terms. You're going to often consolidate down to 3 terms. There's nothing nearly as big as some of those ones we had at the beginning. 7, did you get 7? Okay, what, can you do 7? I'll get back with you. 8?
4a squared minus 8ab plus 3b squared.
All true. 9, sorry, you got fractions.
12x to the third
Yes?
plus x squared y
Yes?
minus 3 halves xy
Yes?
minus 1/8 y squared.
True. All fractions, then no problem. 10? Okay. Can you get me 11? How do you feel about 10's fractions, or do you want to get me 12?
I could try.
Okay, give it a shot.
6x to the 4.
That's a y, but yes.
I didn't run it. Minus 1/2 x y to 1/2 x y to the third.
Yes?
Plus 3 over 5 x y.
Yes?
Minus 1 over 20x squared.
That's perfect. So Nicole gets 12?
Negative 3xy squared
Yep.
plus 2x
Yep.
plus 9y cubed
Yep.
minus 6y.
All true. 13, you could either do off of a pattern I showed you, or if you didn't understand the pattern, what can you always do to square if you just don't like patterns, but you like to just FOIL stuff? Just put 2 of them. Just put 2 of them and do it the same way you're doing everybody else. 13 a shot?
Isn't it like 2x squared plus xy?
It's like that. Try it. Let me come back with you in a minute for 13. Which one were you doing?
Number 7.
7? Okay.
4x squared plus 8xy plus 3y squared.
That's all true. Were you doing something? What were you working?
Number 11.
Okay.
4x minus x squared y minus 2x plus 2
That's all true. Let me just read for a minute through the 14 group. 14, I'm going 25x squared plus 20xy plus 4y squared. Remember that in that middle term, if you're doing my pattern way that I like to do it, what are we doing to that middle term in the pattern?
Doubling.
We're doubling it. So 17 is 4x to the 6 plus a 12x3 y2 plus a 9y to the 4th. 18 is 25x to the 6 plus 20x to the 3 y to the 2 plus 4y to the 4th. 19, we start to get these almost twins who have a different sign. And then we're going to create an answer that has how many terms in 19? 2. Somebody 19, hit me with those.
6x squared minus 4y squared.
Close, not a
Or is it
6.
12 and
A 9. We're going to go 9x squared minus 4y to the second. How about a 20?
oh,
9x
did 3
squared
times 2.
minus 25y squared.
That's true. 21, somebody jump in?
X to the 4th
Yep.
minus y squared z squared.
True. 22?
4x to the 4
Yep.
minus 25x squared y squared.
Yep. 23?
9x to the 4th minus 4.
True. And 24.
25x to the 4th minus 9.
All true. Then let's check back into 13.
Okay, so
Okay, so here's what you want to do is put 2x plus 3y And then if you don't remember the pattern well, forget the pattern. Just put twins like that next to each other. Multiply these, multiply those, multiply those. And those last two that I just referenced, they'll get put together because they're going to be like terms. And then also multiply that final pair. Just see what they look like.
Is it 10x plus something and then multiply?
There's going to be a 12 in there, but there's not anything with the 10. Let's just talk it out. If you multiply these, what would you get off of that? 4. But how about the x's? X times x?
X squared.
X squared. If we multiply these,
That's
6 and,
squared.
no, it would be 6 xy. There's one of each letter. So that's a 6 xy. How about this one?
That's going to be 6x.
Also 6 xy. So put 6 xy and 6 xy together,
12x.
that is 12 xy. And then do this last, final pair.
That's 9y. Okay, I was just looking for
9y
squared.
squared, because y times 1. You good on that now?
Yeah.
25, you could either do 25 by writing 3 of the same thing and doing lots of foiling, or I showed you a pattern yesterday, and that's what I would do. The pattern way for squaring, you always multiplied how many things?
3.
For squaring. Squaring, we were always multiplying 2. So carry that knowledge ahead a step to the ones we're about to do. Cubing, you're going to multiply 3. For squaring in the middle, we had to always square it?
Double it.
We double it. So cubing, we're gonna triple it. Okay, so I was trying to build momentum and transition. You're trying to just jump to the finish line. That's okay. So 25, anybody? 25, think you got it all settled?
Y cubed
Yep.
plus 15y squared
Yep.
plus 75y
Yep.
plus 1.5.
All true. 26 has a minus, so we want to go alternating signs. This is the one that the book made a mistake. Anybody 26, alternated signs?
T cubed
Yep.
minus 21 plus 63 minus 343.
That's close. I disagreed with the
41T.
63. And you did sprinkle in a little bit more T action.
T cubed minus 21t squared plus 147t minus 343.
That's perfect. 26 has some bigger exponents on it, but the biggest number you see is 12. Anybody on 27, you've got alternating signs, your biggest number is 12. There's lots of powers there.
N to the 6
Yep.
minus 6 n to the 4th n
Yep,
plus 12 n squared n squared
yep,
minus 8 n cubed.
true. 28, it's all straight out positives. Your biggest number is 144.
27t to the 6 plus 108t to the 4th plus 144t squared plus 64.
Perfection. Does anybody need me to help you with some of the 216s? We got the answers all out in public, but whether people have issues, I don't know. If you have issues, let me help you. Anybody have anything you're stuck with how to make any of this happen?
Like 9 and 10.
9 and 10. Okay, so 9, are you okay when we look at the first with a 12x to the third?
Yeah.
Okay. Then if I go the 4 thing, multiply the 1/4 thing, that would be a nice cancel. And I would just get an x squared y that could have a 1. You okay with that?
Yeah.
Then if I go the 3 times the half, I'd probably just call that 3 halves
Okay.
and put an xy there. And that's a minus because they were different. You good with that?
Yeah.
And then the half times the 4th, I'll go minus because they're different, 1/8 from the fractions, and then a y squared.
Alright.
You good on that?
Yeah.
10 would be about the same kind of thing. Just kind of take it a little piece at a time. Is that good on that?
Yeah.
Anybody else need any kind of guidance? 216, anything, get any hung up on any of those details? Seemed good at that, which is good, because today we're gonna do almost the same thing, just
Opposite.
opposite. We're just gonna go backward. So, we're pretty used to, hopefully by now in math, pretty much every day in math, the last bunch of years of your life, you probably had a teacher show you how to do something one day, and then the next day they're like, okay, let's switch it up, go backward. So yesterday what we did is largely called foiling. It was all multiplication. Today is like a type of division, but we're not using the word division. We're going to call this factoring. So I have on the board 3 different types of factoring today. We'll have some other types of factoring tomorrow. But this first type of factoring, we're doing something very familiar, but backward, that we did not do yesterday. What kind of factoring is this? What are we doing here but backward that's a familiar friend? Yeah, it's involving a GCF. This could be called factoring a GCF. We're doing what, though, backward when we factor a GCF? We're distributing. So this first group, all we're really trying to do is to distribute backwards. So what you do first, you try to think of a GCF. What's GCF stand for? Greatest common factor. What's that mean? What can a GCF do? It's the biggest number that can divide into all of them. So when we look at these, we think, what's the biggest number that can divide into all of that? And it is 5. So what we do, we write down that GCF in the front, the 5, and then you divide, because you can't. We just said we could, so we do. We divide that by 5, and that just leaves x squared. We leave the plus, we leave the 2. The only way you'd ever change the signs is if you factored off a negative. Just like when you distribute in a negative, it changes signs. If you want to take out a negative, it would change all the signs. But that is now factored. We took out a 5, we left what was left. Something there. And here there's a couple things you can take out, but you want to go big as you can. What's the biggest thing that can come off of all of those? 4. Could have done 2, but if you did 2, you'd have to go again, and you'd rather not do that. So pull off a 4, who's left?
X squared minus 2x plus 1.
Call it a day for now. Something there. This who's coming out?
6y squared.
6y squared. It's not just the 6 that can go into the numbers. Now we're starting to have, for the first time, some variables in common. So if there's a bunch of variables, you always just for the GCF pick the one that's the smallest, because it has to be in common. Even though we just said we want the biggest thing we can get, we need the biggest thing that's in common. So out of these 2, you have to pick the lower one. So 6y squared out. Who's that leave at the beginning? Just a y.
Minus 2.
Agree. Let me double back a second. It's important to leave ones sometimes. It's necessary. If you have a number and you take the whole thing out as the GCF, make sure you leave a 1. Because what we're doing here is dividing in a sense. So 4 divided 4, we need to leave a 1. You shouldn't end up with fewer terms. This one? 2 can come out.
16.
X squared minus 1.
And then we'll call it quits on that column unless there's questions before we move to the left. Anybody a question about distributing backwards kind of stuff? Okay. Okay, so this is the opposite of something we did yesterday. Okay, yesterday there were a bunch of answers we got that looked like this. Does anybody remember what the problems looked like that caused the answers that looked like that? They weren't squares, no.
It was like they were the same thing, but the one had a minus, the one had a plus.
They were the same thing, but one had a plus, one had a minus. And it doesn't matter in what order we put the signs, but what's going to happen to this whole crew is the whole way down this list, we're going to get almost twins, but we're going to get one of each sign in whatever order you happen to put them. And I'm in a little bit of a plus-minus rhythm, so that's just the way it goes. But if you do minus plus, no one cares. Yesterday I told you a name for this type. Does anybody remember what the name for this problem type is, either from what I said yesterday or go back to your Algebra 1 life? It is called a difference of squares. The word difference is always math that we are Subtracting. So the problems all have to be subtracting, and they are. And then what do I mean by squares? They're mostly squared, but the powers at least are gonna be even numbers. So we have to have even powers. If I didn't have even powers, this would not be a trick I could do. And what's true about all the coefficient kind of numbers? What are we able to do to all of them?
Not squared.
Square root. We're able to square root those. Like the square root of 9 is 3, because 3 times 3 makes 9. So this 9 becomes 3's because we're going to square root the number. How about the x squared?
It's just x.
It's just going to be x's. What if it's like an x to the 4th?
And it's just x squared.
X squared. So what are we doing to all the powers?
Cut them in half.
Powers get cut in half, numbers get square rooted, and this is pretty easy money. So who's filling in the blanks on this one?
A's and B's.
A's and B's. A squared makes A's when we cut power in half. B squared makes B's when we cut powers in half. 16 makes 4. X2, X. 25, 5. And then I'll call a timeout, make sure we didn't lose anybody. Again, what we're doing is the numbers, the coefficients in front, we're doing the square roots, powers, cut them in half. Keep the signs different. This is probably the easiest kind of factoring, I would say. Personal opinion. Okay. So this, x4 makes x squared, twins, 25, 5. 9, 3. X6 becomes x3 on a cut in half. 49, 7. Y10, Y5. X4, X2s, Y4, Y2. Question about those. If I wrote a book, I'd stop there. I would do tomorrow's lesson next. I'd come back to these, but I didn't write the book, so I just deal with it. If we go to factor these, anybody have a memory from doing this before?
It's 2 different.
Generally speaking, when things are of that size, you start off and you do make 2 sets of parentheses. What would they start with? Usually x and x to help us figure out the x squared. That's usually x and x. Then there's a rule about the signs.
Is it the last one's the minus?
Okay, since 36 has a plus, that tells us these are the same. And even more detailed, they're the same as the other sign. So these are both pluses. And then you do a little bit of like guess, verify. We always try to imagine numbers that can multiply to make 36. And when they're the same, we add to make the middle. So it's 6 and 6. If this is a different sign situation, we subtract to make the middle. That's what we're going to do yesterday. Okay, we just did or tomorrow. Yeah, what we're going to do. That's what we're going to do tomorrow, I think, is this lesson. This is not where they're going to like keep us today. A memory of what we can do to make this a more likable answer.
6x squared.
Make it x plus 6 squared. That's called a perfect square. And in my opinion, I don't think it makes sense to have people doing the perfect squares before you've done that other lesson. But they did, so we just deal with it. So you can think through that same process that you want to. But if you want to shortcut a homework, if you know it's going to be a square, because that's how they did the book, you can kind of like cheat in a sense. The y squared is going to make y. The 81 is going to make 9. And the sign on this time should be the minus I would not encourage you to do that in the long term. Okay, but for tonight, you could get away with that. To verify, I would suggest you at least do this. When we square, we multiply these to think 9y. But how did we usually make the middle? Double. So think about, just if I did do this and I doubled, would it make that? And it does. So the whole section tonight is going to be perfect squares. So I gave you enough insider information there, you can cheat that. But someday when we take a chapter 5 test and the squares are mixed in with all the other ones, you can't really just count on everything being a square all the time. This one I'm being a meanie, and they will do this in the homework, slight meanie. What's a slight meanie about this one? It's out of order. So if anything's not in descending order, be a little bit suspicious. That was kind of baiting you into doing something with like x, and then you can't do the square root of 20. But if I shuffle that back up, that's the same problem reordered.
Now it's x plus 10.
Now it's x plus 10 squared. What square is this one going to be? Three x from the 9x squared. A plus 5, because 5 times 5 is 45. If we want to verify that, multiplying these would make 15. 15 doubled is 30. It's working. This last one, it's going to be a square. The whole group is going to be squares.
2x
2x for the 4x squared creation.
minus
3 for the 9 creation, minus because of that. And if we want to verify, these make 6x, which when doubled
12.
is 12. And we hit it. I have on my board 3 answers I'd criticize if it were the chapter 5 test. For today, they may not care. They may not even do these. Scan for a minute while I just continue to talk. The homework today, we're going to go 221. 221 pops of 1 to 48. It's these 3 groups in these 3 orders. The first group is going to be factoring the GCF, distributing backward. Then there's an obvious middle group that's going to do these difference of squares problems. Then there's another set of directions where they're doing all perfect squares, I believe. Does anybody see an answer that I would criticize?
Is it the very last one on distribution?
I would criticize this answer,
It's
yes.
just a difference of squares.
Because after we did the GCF, but before we learned about how to do a difference of squares, we need to do a difference of squares now. With 16, we go 4s, x squared, x's, 1s, is 1s, and with different signs. That is now perfection. A sum of the difference of squares section, you'll have to take off a GCF to do it. So if you're in the difference of squares section, and you're like, I can't do this yet, like with 32, if you try to do the thing with the twins, 32 makes an uh-oh, okay? So if you're in the difference of square sections and you have an uh-oh, it's because it's like this one. You need to do the GCF first for the problem to look right. There's 2 more that I would deal with.
Up to.
Okay, this one is also incomplete. 4 is our friend. What can this one do? X minus 1 squared. Okay, this is like one of those perfect squares. So if you're in the perfect square section, this would have been, I guess that might have worked to do it the perfect square way in the beginning. But if you're in the perfect square section, look for a GCF still before you would deal with perfect square action. So that leaves me just one more to hunt down that I would criticize.
One at the very top.
Now I would keep this one. Why is this not a difference of squares?
2 can't be squared.
Because 2 can't be square rooted, and we need a minus. Difference needs a minus. So that one I'm good with. There's one more somewhere on the board that can go.
Is it the 6y squared one?
No, this one's okay. Anytime the GCF's out, it's done. And this didn't have an even power. That doesn't have a number we can read. That's just a dead end. Anybody see it?
Y minus 2 squared.
Where are you? No, these are as good as they can get. Our problem is somewhere in with one of these. One of these has an issue.
Yeah, very bottom.
Very bottom, which one?
X squared plus y squared.
No, I'm keeping that one. I'm ditching this one. Why can x squared minus y squared get ditched? It's like this one was. So how's that one gonna go? X minus y?
X minus y. Or x plus y.
X plus y. This would not be part of the answer anymore. You would exchange this for its two friends. We'd have 3 factors instead of 2. There might be some of these that go and then go again.
Wait, so what is homework 2?
Homework goes to 48, and I think for extra credit, sometimes I'll go like with an x to the 32 minus y to the 32 kind of question, because the 32s become 16s, which become 8s, become 4s, become 2s, become singles, you know, and it goes. Can both factors go? No, just the minus ones. So some get kept, some get ditched. I don't know that I do that for extra credit like in this course, but it felt like, did that ring a air of familiarity from Algebra 1? Like that's like a thing you've probably seen me do to you before. But they keep going. But we're 221, we're 1 to 48, and that's all we got. And then we'll get Mr. Kellner's question, but not on camera. Special guest appearance by Mr. Kellner to the DMR, the Math Wizard channel, waving hi to our online viewing audience.